Everyone, presenting to you Assignment 1 by Group 12 Roboclashers of the course Introduction to Robotics IE 410. Our team members Harmeet Khemani, Parth Parekh, Akshat Joshi, Sahil Sutaria. The aim of our assignment is to determine and implement an inverse kinematic algorithm for robotic system. We are provided the coordinates of the end effector and length of the four links. Our goal is to develop a model that determines the appropriate joint angles Q1, Q2, Q3, enabling the robot to accurately reach and manipulate the specified endpoint. Now moving towards our method. Firstly, we have derived the formula that calculates the angle for the robotic arm for the given coordinates. Then we wrote the code in the C++ using the derived formula. The code will be explained further. Now we move to the connections. Firstly, we have connected the Arduino Uno to the computer using a cable. Now we have uploaded the instructions inside the Arduino Uno using Arduino IDE software. Now moving towards hardware preparations. We disconnect the cable after uploading the code. Now attach the Arduino Uno to an Arduino compatible shield and supply the power using adapter. The robotic arm first moves to its initial position. Then using the go to position, it will move to the position where we have provided in which we have provided the coordinates. It will provide the robotic arm shows the angle Q1, Q2, Q3. Then we have a 5 seconds of delay. The next task is to move the robotic arm to the second desired position. It moves to the second desired position and repeats the similar task and calculates Q1, Q2, Q3. So heading towards our code, we will first introduce the function created. The functions created are radian to degree, degree to radian. On next page, we have functions like square, which gives the output as square of the number provided. The next function is validate function, which checks that if the three angles opted are inside the range, then only it will return true, otherwise it will return false. The next function is go to position function. Go to position function, what it does. So first of all, we run a for loop for orientation angle from minus 165 to 345 degrees. For each angle, we will get the corresponding Q1, Q2, Q3 using the inverse kinematics equations. The next we will check the validate function for Q1, Q2, Q3. That is, if all three angles are inside the range, then only we will proceed further. So next, what we will do, we will calculate the angles are obtained. Now we will what do? Calculate the position from the obtained angles and check the error. So minimum error when we will obtain, we will take the Q1, Q2, Q3 angles and return it. So next is our loop function. Loop function, we provide the first of all we provide delay for 1 second. Then we will provide coordinates of the end effector. First one is x equal to 0 and y equal to 45. Now we will create call the function go to position function, and then we will give the delay of 5 seconds. So for that provided coordinate 0, 45, it will first run the for loop from minus 165 to 345 degrees and calculate the minimum error for which we obtain Q1, Q2, Q3 and produce that as an output. So Q1, Q2, Q3 are obtained. Next, we have an example of 33, 35 coordinate, and we have taken example of 35, 1 coordinate. So accordingly, for every example, it will correspondingly calculate Q1, Q2, Q3 and produce it as an output. Heading towards our video, we have the length of the link 1 71.5 mm, link 2 125 mm, link 3 125 mm, and link 4 60 plus 132 192 mm. Then the robotic arm moves to its initial position. Now we have the first desired position, which is 0, 45. The obtained angles are Q1 40 degrees, Q2 57 degrees, Q3 18 degrees. Then the robotic arm moves to the second desired position, which is 33, 35. The obtained angles are Q1 24 degrees, Q2 13 degrees, Q3 16 degrees. Then it moves to the third desired position, which is 35, 1. The obtained angles are Q1 15 degrees, Q2 12 degrees, and Q3 minus 80 degrees. Then the robotic arm moves to the loop. Thank you.